the practice paper that I've given you. So the first answer is to the multiple choice is question 1. The resultant force is the net effect of all forces. Okay. Scalar quantities are defined by their magnitude. Okay. Vectors have magnitude, direction, and a point of application. Right? Typically, we'll say the big difference between scalars and vectors is that vectors have direction, but we also have to include the point of application. Okay. 3. An atom is made up of neutrons, protons, and electrons. You should probably know the charges and locations of those things. So you should know that protons are neutral and live in the nucleus. Protons are positive and live in the nucleus, and electrons are negative and orbit. Okay, orbitals describe the path of electrons. I'm just including that in there to further explain the questions. Okay. Question 4. A metallic bond has shared electrons in a cloud of surrounding positive ions. For example, all of the in that case, all of the above. So question 4, the answer is all of the above. Okay. Question 5. The SI unit for force is newtons, written as a capital N. An apple is about 1 newton. 1 kilogram on Earth has a weight of 9.8. We can write 10 newtons. 1 kilonewton on Earth is about the weight of 100 kilograms. For instance, football players, Greg Inglis. When I did this, Greg Inglis was the premiership winning team at the time. So these days I say Paul Gallen. Okay, question 6. Okay, Newton's third law is for every force there's an equal and opposite reaction. So Newton's second law is force equals mass times acceleration. Newton's first law is objects at rest remain at rest, objects in motion remain in motion, or things want to keep doing what they're already doing. Okay, question 7. Compounds are the result of 2 or more elements that combine chemically in a fixed proportion. The answer is B, the definition of a mixture. So the answer to B is a definition of a mixture, sorry. Okay, metals are not usually thermal and electrical insulators. They are, in fact, conductors. There's an exception, semiconductors. Yeah? Okay, question 9. The vertical component of the vector is 77.13 newtons in the up direction. It's always important when you give answers to give both the unit and the direction if it's a vector. Okay, I'm going to explain that using SOHCAHTOA. Right? We're using sine equals the opposite over the hypotenuse, which we can rewrite in that way. We're going to use opposite equals hypotenuse times sine theta. Okay. So opposite equals hypotenuse times sine theta. In this case, the vertical component is 120 times sine 40, which is 77.13. Okay. 10. The ability of a material to return to its original size and shape after deformation is called elasticity. A mass of 45 kilograms exerts a force due to gravity of 450 newtons. Now, it doesn't say on Earth, but we assume, if it's not given, that we're talking about Earth. Given that only 12 people in the history of humanity have ever walked on another planet, right? Earth is the number we're going to go with. Okay. Question 12. An increase in carbon content in steel results in an increase in hardness and brittleness. Okay. Question 13. Metal alloys contain quantities of iron are called ferrous metals. Okay. A force of 79 meganewtons is equal to 79 times 10 to the 6 newtons. Right, we have a kilobyte, a megabyte, gigabyte, right? So a kilobyte is 1,000 bytes, a megabyte is 1,000,000 bytes, a gigabyte is 1,000,000,000 bytes, or 10 to the 9. A megapascal is 1 times 10 to the 6 newtons per meter, but we can also remember as a simplification, I call these the grease units, 1 newton per millimeter squared. I have a song that goes with that. It goes, we go together like megapascals and millimeters squared. That is not the last time you're going to hear that song, right? Okay, I got a question. 14 is currently on the board.
No, 14. That's 15.
Okay. Okay, so is the wrong, they don't match up. Oh, 14 is ohms. Okay, it's 15 ohms. Okay, so yeah, this is 15. Yeah, you're right. The thing is wrong. Okay, thanks. So yeah, it's the way we do that. We haven't covered Ohm's law. It won't be in the test for you guys, but just in case future people are listening to this. So the Ohm's law is, I often say V equals IR. So voltage equals current times resistance. In this case, we want to find the ohms, right, which is the resistance. Therefore, R equals V divided by I. So which is V, 12, divided by 0.8 equals 15 ohms. The symbol for ohms is omega. Okay, thanks. I've gone through this before, and never been pointed out. Okay, scope of industry. Now, we've talked about this. I'm not going to spend too long talking about it, right? 5 marks they wanted for this exam. Okay, here are the the colleges of Engineers Australia. Engineers Australia is the organisation that is in charge of engineers in Australia. They offer the chartership, right? So you're not really I don't want to say you're not really a real engineer, but for design engineers, that's the sign that you are now able to work on your own more than anything, is that you're chartered. I was chartered, and then basically as soon as I got my bonus, my company gave a bonus for being chartered. As soon as that bonus was in my bank account, I resigned and then went into teaching. Okay, biomedical engineering, chemical engineering. Chemical engineering has some different subdisciplines. Plastics, ceramics, nuclear and petrochemical. Civil has subdisciplines. Civil, transport, hydrology and geotechnical. Electrical has some subdisciplines. Photovoltaic, so it's solar. Renewable, that's broader. Solar, PV is photovoltaic, is included in renewables. Robotics is also part of electrical. Environmental, right? Information engineering, which includes things like software engineering, signaling, right? It's a big part of transport. Mechanical engineering includes aeronautical, mining, mechatronics. Okay, I won't go through this too much because we've spent entire lessons talking about this, so I'm just going to skip. These are things that this document is on, the PowerPoint that I made is on Facebook. It's better quality than the one I've updated it since. Okay, mechanical engineering, electrical engineering, environmental, chemical, ITE, biomedical. Right, now I've given some details. Now the point I've shown here is it's only small differences between the two. There's only small differences, right? There's still, I mean, in actual practice, these jobs are very different, but in concept, all engineers do very similar things. There's just certain aspects of it that are different. Okay, question 17. There are 3 types of primary bonds. They are ionic, covalent, and metallic bonds. They're the 3 main kinds of bonds. Okay, face-centered cubic structures have atoms that are arranged at the corners and at the center of the cube face of each cell. So you can see that picture there. That's a face-centered cubic, which often write as FCC. The other ones we need to know at this point are BCC and the hexagonal one, which is HCP, hexagonal close packed. So this one here is an FCC. There's also BCC. Yep. I would suggest that these are things worth knowing. Yep. Okay, just having a look here. So here we've got BCC, FCC, HCP. That's what they look like. Now, we've also talked about polymorphism and amorphism. Polymorphism means that we have some things that can be both. If we look at steel or iron, Fe can exist as alpha ion and gamma ion. We can have both of those exist, right? Is there another one there? That titanium can be hexagonal or BCC. That means it's polymorph. It's got polymorphism. It has allotropes. Also, there's amorphism. That means it doesn't fit a crystal. It's a solid, but it doesn't have a crystal. An example of a solid that doesn't fit a crystal is glass. Good work. I was hoping you'd answer that because I knew you asked earlier. Okay, fluids. Fluids can be gases and liquids. What they mean is that they don't they don't hold their own shape. Instead, they fill the container that they're in. Liquids fill the base of the container, whereas gases fill the entire container they're in. Okay, they have higher diffusion rates due to, why do they do that? because they have higher levels of energy and because they have amorphous structures. Yeah, so they don't have a crystal structure. Okay, question 20. Metallic bonds consist of, now this is something you should learn, and we're all going to say it together. Metallic bonds consist of a lattice of positive ions surrounded by a delocalized sea or cloud of electrons. Great. Now that's the picture that you can draw there. Yep. Okay. Characteristics of metallic bonds. Right. I've gone through, used most of them. So they're usually conducting electricity, except for semiconductors like silicon. Yet they have high thermal conductivity. That means they usually will conduct heat very well. They're malleable, which means they can be hammered into a sheet. They're ductile, which means they can be deformed under tension or drawn into a wire. They're usually solid at room temperature, except for mercury. They have high strength. That means they can withstand stresses. They have high density, usually. They usually have high toughness. They usually have high hardness. They usually are shiny, right? That's not really an engineering property, but it's something worth knowing. Now, they might not be shiny all the time, but they're shiny when they're polished, yeah? Now, some of these are not really true, right? So some things some metals don't have a lot of toughness, right? Those orange ones there. But even aluminium is still tougher than something like glass. Yeah? Okay. Polymers can be divided into two classifications, plastics and thermosets. Thermoplastics and thermosets. Another word for thermoplastics is thermosoftening plastics. Now, the difference is that thermosoftening plastics will become soft and return to their original shape if heated. Okay. 23. The process of injection molding consists of 3 stages. Now, this is what you needed for 3 marks. You need to say feedstock is fed into a hopper. This is then the feed is then it's fed into a barrel until its sufficient melt has built up, and in the front of the screw, and the fill shot is injected to the mold and allowed to cool. Now, I posted this to you on the group chat already, but we'll have a look here. This is a more detailed version of the same thing, right? It's just me being a little bit more precise. All that stuff in grey, nice to have, but you don't need it. The stuff in green is what I think is essential. Okay. Now, this is for thermosetting polymers, right? Because they asked for a thermosetting polymers. In the case of thermosetting polymers, there are differences, right? A thermosoftening polymer is tapered in order to build up heat. They have heat lamps, but it's also tapered to build up heat and pressure. Whereas thermosetting polymers, they're epoxies. They produce their own heat. Right? We can color. We can add color into a second hopper with thermosoftening polymers. Anyway, I'm not going to get too worked up about that. I'm going to move on now. 23b. One property of a polymer that makes it suitable for a crisper draw is, now they didn't ask what material you wanted. They just said what are some properties. Thermal resistance. So that means that it can function at boiling temperatures, because sometimes people clean out their freezer drawers with boiling water. I've done that. But it also needs to work at low temperatures. Yeah, so it also has to work at 4 degrees. So it has to be stable at a range of temperatures. It can, so it can also need to be durable, right? So it doesn't corrode, it doesn't rust. Yeah, it lasts a long time. It needs to be transparent. It doesn't need to be transparent, but I'm suggesting that's a good thing to know, so that you know that you can reduce the number of times you open and close the drawer if you can see what's inside it. It also helps you to know where the smell's coming from. Okay, it needs to be strong. That means it needs to be able to resist loads. You don't want something that's cracking on you. You don't want something that breaks after a short amount of use. Now, half-mark thermal insulation. Yeah, that's pretty true for all plastics. I'll give it. Yeah, I would have given thermal insulation, but it wasn't something that I was looking at as being specific for that case. Okay, moments. Now, I can say if you're doing this test in 2018, I'm not testing you on moments, but in future classes, you might have to know about moments. Moments are equal to force times distance. Yeah, so I did tell my 2018 class that they... Wait, what are we, 2017? Yeah. Oh, it might apply for 2018 anyway. When I mean 2018 is the graduating class of 2018. That's why I get confused. You're the potassium class. Anyway, look, force moment is equal to force times distance, right? If you go through that question, the answers are there. I'm happy to go through that with anyone who wants to know about it early. Okay, so this is how I broke up the marks. Okay, resultants. Now, I am saying that this is going to be in the test. I'm making it really clear. Now, I've gone through this on the board, and I've got a video of me going through that on the board. But the idea is that we want to take that force. I'm just going to show you that animation again. We want to take those three forces, and we can add them tip to tail. If we do that, we can then find our resultant by breaking up our components and finding our missing part. So if we go from start to finish, we can use our components to find our resultant. Yeah, ultimately the shape needs to close. Yeah, the resultant will be the shape that's needed to make it close. Okay, now in this case, the length is root 2, right? So it's 141. Root 2 is 1.41. So I knew that the answer for those horizontal components was going to be 141. Okay, so what I've done is I've just added up all of the vertical components to get this is the total of all my vertical components, this value here. And then I did the total of all my horizontal components to get this value here. When I do that, I'm going to be able to find, using Pythagoras' theorem, if I know the square root of the vertical components and the square root of the horizontal components, sorry, the square of the vertical components, the square of the horizontal components, if I take the square root of that sum, I can get my resultant. Now, I then need to find the angle, which I haven't done here. Okay. Same thing, you can see the animation. We add these vectors tip to tail, and our resultant is going to be from start to finish. It's what we need to close, that shape. Yeah, to close that shape. The resultant goes from start to finish is what we need to close that shape. So what I did is I found the components first. Right, so I found the vertical component is 37.5, the horizontal component is 64.95. I added up all of my vertical components, I added up all of my horizontal components. I took used Pythagoras' theorem to find out what the resultant was, right? And that gave me my resultant, right? Now, we didn't do the angle here, but I did do the angle on, oh, there we go. Okay, how to find the angle. In this case, I found the angle. So we use tan equals opposite divided by adjacent. That's the definition of tan. Tan theta equals opposite over adjacent. So in this case, what we need to say is tan theta equals the vertical component over the horizontal component. So what I can use is the arctan, or on your calculators, it's tan, the inverse of tan, right? The arctan, the atan on Excel, to find the angle is 39.75. Again, I went through that in more detail. Here's the breakdown of marks. Half a mark for showing me the vertical component, half a mark for showing the horizontal component, half a mark for doing the addition, right? Half a mark for finding the resultant, half a mark for writing the letter N, half a mark for showing the angle, the direction. Now, just before I go on, if you get it perfectly right, you don't need to worry about those things. But if you get it wrong, you don't get those half marks. Right, those half marks matter. Now in the HSC you don't get half marks. I will give half marks in this test if needed. Yep.
With that bit, how'd you get
The negatives, because see how it's a good question. I'm saying that the positive is up. So if the direction of the force is going up, yeah, it's 50 up.
Yeah.
Here it's 50 down.
Yeah.
That's how you use Excel to find it. The method that I used on the board is a little bit different. Yeah, I'm happy to go through that in more detail with people later, but for the moment, there is a detailed working on a video of that already. There are two kinds of electrical charge. What are they? Great. Yep.
Did you have that answer for A? You only showed B.
For the addition of vectors,
Yeah, that was A.
I did both. Yeah.
What was the A?
That one. Okay, charges of subatomic particles. Protons are positive, neutrons are neutral, electrons are negative. Electrical insulators resist the flow of electric current. Now, we covered this as part when we did the atoms and bonds section. Yeah. The electrical insulators resist the flow of electrical current. So Metallic bonds, they have free electrons. They allow electrical current to charge to flow. On the other hand, ionic bonds, that lattice isn't going anywhere. All those ions are trapped. There's nothing free to allow the charge to move. Covalent bonds, same deal, right? They've got nothing that allows that charge to move. Electrical conductors allow the flow of electrical current. They need to have, right, for that to happen, they need to have particles that can carry the charge, either ions or electrons. So when we talk about water, water doesn't conduct electricity. But if you dissolve salt, suddenly the ions that are in salt, the Na and Cl, the sodium and the chloride, those charged ions are now free to carry electrical charge. Yeah, so that's why salt conducts water, because of the ions dissolved in the water. Water itself, it's a covalent bond, can't carry charge. Ions typically can't conduct electrical charge. But if you dissolve ionic bonds in water, suddenly those ions can conduct electricity. This probably won't be in your test. It's me just over-explaining. Okay, electronics. We haven't covered this for the people listening to this in 2017, the class of 2018, my potassium class. But students, other classes might need to know this. A diode. Okay, we talked a little bit about this. The diodes are made from two layers of semiconductors. The semiconductors, basically, one has a little bit more electrons, the other one has a little bit less electrons. As a result, it only allows electricity to flow through in one direction. Diode only allows one direction, right? I don't know if you guys are familiar with the band One Direction, if that's still relevant, but you know, there was the band with Harry Styles, You've Got That One Thing. Yeah, they only allow electricity to go in one direction. So when you're thinking of diode, think of a English boy band. Okay, LEDs are a specific kind of diode. They're light emitting. How we draw that? Well, this is the symbol for diode, this triangle and a line. That's how we draw a diode. If we draw two lines coming off, that's how we know it's an LED, right? It's emitting light. The other way is, instead of writing those two arrows, we can write the Greek letter lambda, right? If anyone's ever played Half-Life, that's the symbol. The Greek letter lambda, and that means for light. Okay. Lastly, we've got this drawing, right? We've got a third angle projection. We can tell it's a third angle projection because I've got this symbol here. I know it's third angle because I've got the target and then the flag. If it was first angle, it'd be the flag, then the target. Yeah? Now, the flag is always drawn like a less than symbol. Okay? Now, what do we need to draw? We need to draw a top view on top. That's what we do in Australia and English-speaking countries, because we use first angle projection. Whoa! Bad, Mr. Punter. Right? We use third angle projection. Right? What I meant to say was that in France, right now, I've lived in France. I quite like France, but I like to say stinky France because people think of it that, you know, hey, stereotypes. Right? They use first angle projection, which means they put the front view on the top. It's crazy. It's crazy. I don't know why they do it. That's what they do it. Okay? I know it's crazy. You don't need to worry about it because in Australia we use third angle projection. Right? Target, then flag. So we draw the top view. Right? I draw my top view and it looks like that. Now you can see my slots for the toast. You can see the rounded edges. I didn't color it in. I didn't render it yet. I'm showing just the outlines. Now, you can see my light, thin lines. They're my construction lines. That means that everything should line up. Everything should line up. Now, I've used these dark dotted lines. Now, those lines should be a little bit darker. They should be dark dotted lines. If I was going to update this, I'd make those dark dotted lines. That's hidden detail. That's showing that there's something going on in the inside. And the same thing about hidden detail here, right? To say that I've got two slices. I've then got this panel on the outside. I really should be able to see that panel up here. I'm a bit disappointed in that. Let's have a look at my marking guidelines. Okay. They asked for 6 marks, right? If they ask for 6 marks, draw this symbol. All right, it's a lot of marks for this question. It's a pretty simple question. So draw that symbol, the third angle projection symbol. Okay. The shape. Does it basically look like a toaster? Yeah? Yeah? Okay. Dimension transfer. That means that these things, I call that alignment these days, right? Do these shapes, do they match up? Does this shape line up with that shape? Yeah? Okay. Did I label it? Yeah? Top view, front view, side view. Printing, what was the quality of my printing? Was it labelled well, or was it just labelled with lowercase writing? It was really sloppy. In Australia, your printing should be 3.5 millimeters tall. Yeah, it should be all capitals. Yeah, as long as it's 3.5 millimeters tall and all capitals, I'll probably give you the mark. Right? There's a little bit more of a specification. Can someone hold up one of those sheets that I passed out? Right, the one with the grid paper. Yep, can you turn that around, please? Yeah, this is great for the people listening on the video, but can you turn that around? Turn the page around. Yeah, can you see those printing guidelines? Now, personally, I've been taught to never have slanted printing, but it's not wrong. Orientation. Orientation means the top view is on top. Yeah? The last one is line quality. Now, when I did this, I picked up this paper from someone else. They said that they insisted it had to be freehand because it specifies freehand. I disagree. I think it can be ruled. But what I don't want to see is if you do it freehand, I don't want to see feathering, right? That we're not in arts. This is technical drawing. You draw one solid line. You don't draw a whole bunch of little lines. You do one solid line, right? I also need, if I was marking, I might change this to say I need to see a difference in line thickness. That's really important. I need to see a difference in line thickness. Now on Facebook, I've given a marking guideline for this exact question. It's a little bit different. I'd use the one that's on Facebook. I think that's more accurate. Okay, that's the end of this exam. We covered that pretty quickly. And